Green and yellow? Pack your colors? Ooh. Alright, so I'm going to use green and yellow as we go. We're not going to use them a whole bunch, just a little bit as we go through. So go ahead and label 3-5, part 1, proving lines parallel. We'll get started in about 45 seconds. Taking your notes out, getting them labeled. If you want to, you can also use colored pencils. There's really no reason I'm using highlighters today. Just because I wanted to. Switch it up for funsies. What? I hope you remember. Yeah, it's putting a lot of trust in me. Alright, about 30 more seconds and we'll get started. Getting antsy when I get to that last 30 seconds. I start sooner than I say. Alright, you guys look ready? So go ahead and make sure that your phones are put away for right now. We actually don't even need your calculators, so you can put your computers away. We're all just straight up using your brain knowledge. How exciting. Okay, so first off, we're going to talk about that word converse. Today we're going to be working with converse theorems. Does anyone remember what chapter did we work with converses? Lucky for you, guess what we've been making this whole time? A table of contents, right? Switch back to your table of contents. Where do you see that word? Where might we be working with converse? Well, it's not in our table of contents. I thought it was going to be. I was really excited.
Yeah. Switch it. So that might be with that word like counter. So that's what we were looking in chapter.
So converse was when we had switched places. So we were dealing with that conditional statement. So a conditional statement was that if-then statement, A goes to B. And then our converse, we switched that places as B goes to A. You don't have to. Well, they don't have it.
I know, but it's...
Okay, but then it'll have more magic to it. Okay, so converse means that we switch those places of our high conclusion. So remember, it's a if A, then B. If that's our original, our converse is going to go if what first? Good job, class. If B, then A. So that's that converse. So we're going to be working with the converse of some theorems that we already worked with this chapter. In chapter 3, we worked with some theorems back in 3.2. Okay, so I'm going to flip back to 3.2. 3.2 is where we had that nice foldable that a lot of you were using yesterday, which was great. Okay, these were all theorems. Postulate, theorem. In these problems, it started with if two parallel lines are cut by a transversal. So we're starting with parallel lines. Then we could say corresponding angles are congruent. Or then we could say alternate interior angles are congruent. Or consecutive interior angles are supplementary. So we're going to do the opposite. We're going to switch them. Not opposite, we're going to switch. So to switch, we're going to start by saying the corresponding angles are congruent. If corresponding angles are congruent, then the two lines are parallel. If the alternate interior angles are congruent, then we can conclude that the two lines are parallel. Okay? So we're going to just list those really quick. We're going to take some time to draw some of those out. just to remind ourselves what they look like. Most of you, from what it sounds like in that warm-up, did really great at remembering these. Okay, so we're going to start with this hypothesis. If two lines, we don't know if they're parallel, we just know that there's two lines, are cut by a transversal, so that dot. Because really there's four converses we have here, and rather than writing that sentence 4 different times, we're going to just break it up into 4 different parts here. So if two lines are cut by a transversal, so that our first one is that corresponding angles are congruent. We have some tissues back here if you need it. Whoa, that's a weird looking congruent sign. Let me try that one more time. So corresponding angles are congruent. So we're going to have two lines. Do we know that those two lines are parallel? Nope, doesn't say so. And they're cut by a transversal, so they're cut through with a line. And we know some corresponding angles are congruent, so we're going to mark two corresponding angles on this diagram. So I'm going to mark this one here, and this, the corresponding there. If I start at that intersection, it's like I'm going to the left and down. Okay, so if those are congruent, then what I can say is that these lines are parallel for a fact. I can go backwards and say that if that's the case, these are the same, then I know that these are parallel. Back in 3.2, we had to say that they're reversed, and we had to draw parallel lines.
So what we'll be doing today is thinking about, we don't know if they're parallel or not, but can we prove that they're parallel because we know this relationship?
Okay? So if the corresponding angles are congruent, then we know that those are parallel. Okay? What about alternate interior angles?
So look back at that puzzle if you need to. What do we know about interior, alternate interior angles? Good.
Yeah.
And do we know they're congruent?
So if we know that they're congruent, even if the picture doesn't make it look like the lines are parallel, if we know that they are congruent, we can say that these two lines are parallel. Now the way I drew it, does it make it look like those lines are parallel? No, it looks like eventually they're. But if I show that this angle on the top is congruent to the inside angle on the bottom, no matter what the picture looks like, I know that those lines will be parallel. Okay, and I'm using those two arcs. Remember when you see those arcs, that tells us that those angles are congruent. All right, what about our consecutive interior angles? What should be the deal with consecutive interior angles? I'm gonna 100% pretend I was listening and not focused on my drawing. What'd you say? Good. Inside angles on the same side of the transversal. So I'm looking at like this angle. It's on the inside between those lines. And then the consecutive would be same side. Do I want those to be congruent? What are they? They add to 180. They're supplementary. Good. So because they add to 180 and they're the same, I'm going to mark this one with those two arcs to show that it's different. So these might be different. They might both be 90, but they're going to be different. But what I know about them is that they are supplementary. Which, remember, means that they add up to 180. So when I mark this one, I'm going to mark it with two different colors to show that those are the angles I'm looking at, but those angles aren't necessarily equal. They're not congruent. They add up to 180. I think my yellow and my green look a lot alike today. Those may be Packers. Always just seeing too much. Looks different on my paper. Does it look different up there? Yeah. One is yellow, one is green. Whoops. Okay, we know that those are supplementary. They add up to 180. And then there's one other converse that we're going to work with. So we have corresponding, alternate interior, consecutive interior. Can anyone figure out what might be our last one? As they dry, it looks better. What's our last relationship we're going to work with? Good. Alternate exterior. And what do we know about alternate exterior angles? Alternate means opposite sides. Exterior would be the outside. So what do we know about outside, opposite side angles? What's their relationship?
Go back and look in those notes if you need to.
Are they congruent? Are they supplementary? Are they complementary? Congruent, yep. So I like to put that just that simple congruent because that's easier than writing out the word congruent. If you see that symbol and you're like, what the heck? Maybe write same or equal or congruent next to that. So because they're congruent, I can use the same number of arcs to show that they're congruent, they're the same. I'm going to go with this bottom one here. It's kind of my go-to angle, I don't know why. And then I'm going to go to the other intersection, the other line, and I want to go to the outside. So I'm going to go to the right, and I want opposite. So here it was kind of below that transversal. This time I want to go above that transversal. So I can just mark those with that one arc, and that shows that these two match. They're the same. They're congruent. Or we can use some colors to color coordinate that, saying that this is... Alright, but remember we're writing a converse of these theorems. So our converse starts with saying if they're cut by a transversal so that the alternate exterior angles are congruent, we have to have a conclusion. And conclusions start with what word?
So we're getting to that. We said if, blah, 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 then what shows us it's the conclusion?
Miss Slider just said it. It's funny.
We have to go over like statements.
So if is that hypothesis, what word starts our conclusion? Then. Miss Sawyer said, if we have an if, then. So for all of these, it starts with if two lines are cut by a transversal, and then one of these things has to be true. Then the two lines end up being parallel. So that's our conclusion, our ending statement with that. And I'm going to just kind of draw a line across, showing that that is all kind of one big chunk. So we have 4 different converses there. I'm going to label that on the side that these are converses. 3, 2, converses. All right, we have one example that we're going to work through, and then you'll have the rest of the time today to work on your practice. I lied. It's like 3 different examples, but we're going to just do one drawing. I don't know, man. You'll understand as we go, I promise. Maybe you won't. I don't know. Making promises I can't keep. All right. Sound like a politician today. Just kidding. All right. Haha, Miss Morale, you're so funny. Thanks, guys. We love having you as a math teacher. I love having you as my students. Oh. Okay, good conversation. Are any lines parallel, and why? That's our directions today. Which doesn't make sense because we don't have a picture and we don't have any information. So we're going to draw a picture, but that's the idea of a lot of your practice work today is going to ask which lines are parallel and why. And they'll give you a picture with some information, and you'll have to decide if any of the lines are parallel and which converse, which one of these ones on top, tell us that answer. Now I will say you guys are more talkative today than normal, which is very surprising for a Wednesday. Good job. Crushing it. Good job, Jaden. Good job, Isaac. Good job, Hubach. Good job, Yusuf. Does it help when I say your names? Good job, Nelson. Good job, Anthony. Okay. Are any of the lines parallel? So we're going to draw this 3 horizontal lines. So you may want to draw this with me if you're not ready yet. Maybe pause what you're doing. Draw this line here. We're going to call that line A. So we use a lowercase. It's supposed to be like an italic A. I don't know. I just draw A. Okay, we're going to draw another line down here. We're going to call that B. And we're going to draw one more kind of horizontal line. And we'll call that C. How are we doing so far? Got the drawing? So 3 lines that are horizontal, they're going a little bit side to side. We don't know for a fact if any of them are parallel. We don't have any of those markings. They look parallel, but we're not 100% sure yet. We're going to have a transversal cut through all of them. So we're going to draw a line that goes through all of them, a little bit more vertical. And this line is L. So that transversal is going to be line L. For lowercase l's can look a lot like 1s. So in math, we like to make them that loop-de-loop L. But that's really a lowercase l, so that way we know it's not a 1. All right, now we're going to label just 4 of the angles, because we only are going to do 3 examples. And we don't need to label all the angles, because that just is excessive. So we're going to start by labeling angle 1 is going to be right here, by where angle A and I'm sorry, where line A and line L intersect, angle 1 is going to be in this bottom corner. Okay, we're going to jump down to line B. On line B, we're going to label both these bottom angles. The one on the left will be 2, and the one on the right will be angle 3. And then down to line C, we're actually going to go above on line C, off to the left. And that's going to be, so that's really important that you have those in the right spots, because as we work, we're going to be talking about those relationships that those angles have with each other. And we're going to just do 3 examples. We'll have enough space here that's pretty short. Each example takes up like 2 lines. So if you have 6 lines, you're good to go. Alright, so example 1, we're going to be given some information. When you hear that word given, hopefully you're thinking a little bit about proofs. We're not really proving anything today. Well, actually we are proving. We're just going to be doing it in one step. So our given, we know that angle 1 is congruent to angle 4. And we want to see if any of the lines are parallel based on that information. So angle 1 has to do with which horizontal line? A, B, or C? For angle 1? That goes with line A. And what about angle C? So we're kind of ignoring this B. I'm going to just kind of put my pencil over it so that we don't see that. We're ignoring that B completely, because it has nothing to do with that B. Now, if I take a look at angle 1 and angle 4, is there a relationship between those of one of the 4 things we mentioned above? Are they corresponding, alternate interior, consecutive or alternate exterior? What? Good, alternate and with alternate interior angles, in order for things to be parallel, my alternate interior angles have to be congruent. So are 1 and 4 congruent? Yeah, it told us 1 and 4 are congruent. So what 2 lines are going to be parallel? Good, A is parallel to C. We're going to use that symbol for parallel, so we're going to say A is parallel to C. And we have to give a reason why. So which of those converses did we use? What was that relationship between 1 and 4? Good, alternate interior converse. We need to have that word converse because that converse is what tells us that we started with the angles, then we said that the 2 lines are parallel. Okay, if you need to abbreviate, you might abbreviate alternate or you might abbreviate interior. Alright, number 2. We have 3 examples today. So make sure you're giving yourself enough space to do all 3. Again, they only take up a couple lines. Alright, in number 2, we are given that the measure of angle 1, so it's going to give us an actual degree, an amount that angle 1 is equal to, is 103 degrees. And we know that the measure of angle 3 is 100 degrees. So our first step is to locate where is angle 1 and where is angle 3. So angle 1 is at the intersection of what two lines? Line A and line L is angle 1. Where is angle 3? Yeah, and angle at line B, right, and L. Are we dealing with line C at all in this one? Nope, so I'm just going to cover that one up. Pretend it's not there. Okay, I'm looking at 1 and 3. What's the relationship between 1 and 3? Are they corresponding, alternate interior, consecutive interior, or alternate exterior? What told you corresponding? Yeah, they're in the same position. Are they both exterior, both interior? Nope, we have one of each, and they're both kind of on that left side, so that's corresponding. According to our corresponding postulate, converse, our corresponding angles have to be congruent. So our angle 1 and 3, are they congruent? No, how do you know they're not congruent? Yeah, angle 1 is 103. What's angle 3? 100. Are they the same? Nope, so they're not congruent. So we know for sure angle A is not parallel to angle B, but do we know anything about A and C or B and C? No, doesn't tell us anything about C. So rather than saying that we know A is not B, we're just going to say no conclusion. Which just means that we can't use any of our theorems or any of our converses to say anything. It's just, we got nothing. Nope, doesn't tell us anything about the parallel. All right, last one, number 3. Guys are crushing it. We are given, and again we have some measures here. We know a measure of angle 2 is 127 degrees. And the measure of angle 4 is 53 degrees. Now, this is like a completely brand new problem. We're pretending number 1 and number 2 don't exist. We're just using the same picture. So some of you that are looking and you're like, 2 and 3, this can't be 100 and this can't be 127 at the same time. You're right. We're just pretending number 2 and number 1 didn't happen. We're starting fresh on this fresh new diagram. That's why we haven't been marking it up, because we want to make sure it's nice and clean for each one. Alright, so our first step is to locate where is angle 2 and angle 4, and is there a relationship between them? So what two lines would we be comparing when we look at 2 and 4? B and C, because we have 2 and 4, so angle 1 is kind of left out of it, right? Or sorry, line 1 is left out of it. What did I just say? Angle 1, line A. I don't know, man. Okay, so we have 2 and 4. Is there a relationship between 2 and 4? Yeah, what's that relationship between the two of them? Good, consecutive interior. And what do we know about consecutive interior angles? What should they be in order to make parallel lines? Should they be congruent? No, they should be supplementary. A lot of you said that, and then I ignored you for the first time, so thanks for saying it again. Okay, they're supplementary, which means that they should add up to 1/8. Does 127 plus 53, does that make 180? Are you sure? Did anyone actually add it, or are you just assuming your teacher told you? 7 plus 3 is 0, carry the 1. 5, 6, 7, 8. 180? It works. So because they're supplementary, 2 and 4 are supplementary, which lines are going to be parallel? B is parallel to C. We don't know anything about A. It doesn't tell us any information about that angle 1. So that's all we can say is B is parallel to C. And we need to provide our reason, our why. So what was that relationship that we used to prove that they were parallel? Good. Consecutive interior. And then what's really converse. That converse is what allows us to go from angle measures to saying that they're parallel. If we just leave it as consecutive interior, it'd be like we're working that problem backwards. It would tell us that they're parallel. Then we can say that.